Let's have a look at variation. Similar to combination, it has got two types, without repetition and with repetition. Without repetition could be an example of ways in which 3 out of 10 sports people can win a medal in a competition. The first win in gold, the next silver, and the third bronze. So as you can see, in this case, the order does matter, because it does matter who gets the first prize, it matters who gets the second prize, and it matters who gets the third prize. And since people cannot be repeated, one person cannot be first and cannot be second, this is variation without repetition. As for the variation with repetition, the example could be four-letter words using the alphabet of 11 letters. So in this case, letters can be repeated, therefore this is variation with repetition. And the order does matter, so it matters in which order we select the letters, because each time we change one letter, we get a completely different new word. So let's have a look at the formula for variation without repetition. It's very similar to combination. The only difference is that we don't have any more this k factorial in the denominator. And the example could be the selection of 3 students in a particular order out of 10 students. So in this case, it matters in which way we select the students. And since people and students cannot be repeated, this is variation without repetition. So when we insert everything into the formula, so we select 3 people out of 10 people, we get that the number of ways those students can be ordered is 720. And here you can see the formula for the variation with repetition. So we select k elements out of n elements, and we get the following formula. So n taken to the power of k. For example, how many codes of 4 letters can you get with A, B, and C? So once again, in this case, it does matter in which order we select A, B, and C, because every time we will get a completely different code, a new code, a unique code. So it does matter in which order we select the letters. And this time we are selecting 4 letters out of 3. So at least one letter will be repeated. So we take 3 to the power of 4, and we get that there are 81 ways, or 81 codes, 81 unique codes. There could be some other examples of variations. For example, we can assign 5 trophies to top 5 competitors out of 10 participants, and each trophy is unique. One is for first place, then the next is for the second place, and so on and so forth. So once again, it does matter in which order we select those trophies, because everyone wants to be first, and so on and so forth. Another example could be the possibilities to choose 2 representatives out of 100 students, one as the president and the other as the vice president. So once again, it does matter in which order we select those people, because each person will get a unique position. So one person will become a president and the other person will become a vice president. And another example could be the different even numbers composed of 4 digits that can be made with digits 1, 2, 3, 4, 5, and 6. So once again, here we're selecting digits, we're creating unique numbers. So it does matter in which order those numbers are put, because every time we change at least one number, we get a new unique number, and therefore it matters how those numbers are selected, how those numbers are put.